Hey everyone, Alex is here. Welcome to my Generative AI crash course. Today, we're exploring the fascinating world of large language models, or LLMs, specifically a crucial component, the attention mechanism. We'll break down the technical aspects in a way that's easy to understand even for non-coding experts. LLMs process sequences of information, for example, words in a sentence, pixels in an image, etc. A major challenge is figuring out which parts of this sequence are the most important when generating a response. Imagine reading a sentence. The dog chased the ball across the park. The model needs to understand that dog and ball are key to the action, while across the park provides context. This is where the attention mechanism comes in. It's the model's ability to selectively focus on the most relevant parts of the input sequence. Let's consider illustrative example, the matrix. We can define attention as the ability to determine the relative importance of each component in a sequence relative to the other components. Do you remember the cult movie The Matrix? In this episode, Neo doesn't just see a sea of people, he focuses on a woman in red. The attention mechanism does something similar. It filters out the less important information and concentrates on what matters the most. If the entire crowd were red, his attention wouldn't single out that one person. It's about relative importance within context. Hence, the context is king. Let's look at an example with the word bank. In I swam across the river to the bank, the word bank refers to the river edge. But in I went to the bank to deposit cash, the word bank means a financial institution. The surrounding words, or the context, completely change the meaning of the word. The attention mechanism helps the LLM understand these contextual nuances. Attention weights. The attention mechanism works by assigning weights to each word or element in the input sequence. These weights are numbers that represent the importance of each word in relation to the others. Higher weights mean the word is more relevant. These weights are calculated dynamically and depend entirely on the input data, leading to the context-aware nature of the model. Technically speaking, attention is the ability of a network to give different weights to different input values based on their position in the sequence or tensor. Under the hood, the attention mechanism involves three key components: queries, keys, and values. Think of it like a database lookup. Query represents what the model is looking for. The keys are the words or elements in the input sequence. The values are the associated information with each key. The model uses query to find the most relevant keys and then passes those keys to pull corresponding values. The attention mechanism calculates attention weights based on the compatibility between the queries and the keys, resulting in a weighted average of the values. The mathematical function responsible for this is the attention scoring function, often involving matrix multiplications. It needs to be efficient because the amount of data, or the size of database D, could be massive. The attention weights, after being normalized using a softmax function, making them positive and adding up to 1, represent the strength of the relationship between the query and each key in the input data. These are then used to compute a weighted average of the corresponding values, which gives a contextually aware representation. The attention mechanism in front of you works as follows. A query queue, think of it as a user's request or prompt, comes in. Second, the attention scoring function alpha calculates how well the query matches each key in the input. To do it, the alpha function is applied to all combinations of the query queue and available key I in a database D. This is how we get attention weights for each token in a sequence. Softmax function normalizes these scores into non-negative probabilities or attention weights. These attention weights are applied to the values, creating a weighted combination. It is done through a pairwise multiplication of the attention weights and the values V, extracted by corresponding keys K. A linear combination of the results of multiplication is called attention pooling. It produces the contextually aware output for the query Q. Let's map the theory and practice. Batch multiplication is an element-wise multiplication of vectors of queries and keys, represented by a standard torch operation BMM. Masked softmax is a typical softmax operation with only one exclusion. It masks blanks from attention inputs using a binary operator. Dot product self-attention class brings all the elements together. Here you can see how LLM use a query to pull up keys from a lookup table and then find the most relevant keys using the attention scoring function. Here how we get scores, attention scores. In a softmax function later, these scores is turned into the non-negative probabilities or attention weights, step number 2. Finally, the attention mechanism returns a linear combination of the attention weights and values extracted using the corresponding keys, step number 3. This is how the contextually aware output for the query queue is produced in LLMs. Takeaways. First, context is crucial. LLMs aren't just memorizing, they're understanding context. The attention mechanism allows them to weigh the importance of different parts of the input, leading to more accurate and nuanced responses. This is why the same word can have vastly different meanings depending on its surroundings. Second, attention is a selective focus that drives information prioritization and coherence. Think of it like your own brain focusing on specific details while filtering out irrelevant information. The attention mechanism does the same for LLMs, making them efficient and effective. The ability to focus on relevant parts of the input is what allows LLMs to generate coherent and meaningful text, images, or other outputs. Without attention, responses would be disjoint and nonsensical. Underlying math could be complex, and also it constantly evolving. We remember queries, keys, values, weights, but the core concept is simple: prioritization of information. The field of LLMs and attention mechanism is constantly evolving. New techniques and improvements are being developed all the time, leading to more powerful and sophisticated AI systems. That's it for today. Thank you for being with us and see you in the next series. Don't forget to subscribe.